Welcome to clickmyproject.com. Let's discuss on the paper Algorithms for the Digital Restoration of Torn Films. In this paper, we present an algorithm for the digital restoration of films damaged by tear. Our proposed system contains two stages named as detection of defects followed by removal of degraded pixels. Adaptive histogram shape-based thresholding is applied for creating defect map. It is nothing but finding the degraded pixels. The quality of degraded pixels will be enhanced by constructing image prior structure over extended image neighborhoods. We give a new solution for the challenging tasks such as modeling image priors. Due to the high dimensionality of images and their non-Gaussian statistics also, we have to model correlations in image structure over extended image neighborhoods. We quantify our performance by computing the quality measures such as PSNR and MSC. Now let's see the explanation of this data flow diagram. The first block in this DFT is nothing but input image damaged by a tear, that is our input image. The second block is threshold determination. Under this, the given image is represented as intensity matrix that is consisting of values. It lies in the range of 0 to 255. Histograms plotted for each of the intensity values and threshold points are found. The defects can be distinguished by assigning an arbitrary pixel value or average pixel value to the regions separated by thresholds. After determining this threshold, next step is we have to generate the defect map. After getting this threshold value segmentation, it will be started to generate the defect map. This will produce a binary segmented image consisting of two groups. The first group is consisting of all pixels with gray level values greater than threshold, and the next group is consisting of pixels those who are having values less than or equal to threshold. This defect map will be useful for the restoration of old RQ input film. Come to the next block, that is blob deduction. This blob analysis is used to calculate the statistics for labeled regions in a binary image. The block returns quantities such as the centroid, label matrix, and blob count. The finally bounding box measurements also. The detected degraded pixels will be enclosed by means of bounding box. Come to this, that means the construction of image prior model structure with the help of this training data set. The image prior structure is constructed over the extended image neighborhoods. Actually, this training data set is nothing but the collection of various images that will be used for the construction of prior model structure. Under this, we have to train this on some generic database. The parameters are automatically learned from training data. The image prior model, it permits fewer experts than dimensions, that is under complete, or equally many, that means more experts than dimensions. Come to this block, enhancement of degraded pixels. We have to develop a parametric representation that uses examples for training, but does not rely on examples as part of the representation. So first we have to project the image patch onto a linear component that is equivalent to filtering the patch with a linear filter. So filtering is done here. After this filtration, the quality of each and every degraded pixel will be enhanced. Now this enhanced images obtained at this stage, it will be better when compared to the original degraded image. The quality of this enhanced image, it will be measured by computing the quality measures such as MSE, PSNR and contrast to noise ratio. Now let's see the execution of our proposed system. This is the main file, restore main.yum. Select the option run file. You will be shown a file dialog window for the selection of input image. Now I am selecting the first one. The defect detection followed by the enhancement process will be going on. In the command window, the number of iterations that are under proceeding is displayed. It will take some time for the enhancement because since it's a linear filtering approach, because we are developing a parametric representation and that will use the examples for training, but it does not rely on the examples that is as part of the representation. So first we have to project the image patch onto the linear component that is equivalent to filtering the patch with a linear filter. So for filtering the overall image, it will take some time. So we have to be wait for seeing the output result. The currently displayed figure window, it shows the segmented binary image. This is the result at the end of the execution of adaptive histogram thresholding. Now we got all the results. Let me explain you one by one. Now this is the original input image that is selected by the user. Now see, this image is having the damages. Here and there the damages are in this image. Now the second one is the result of adaptive histogram threshold block. So the defect regions are now represented as white pixels. The remaining area, non-degraded region, is represented by black colored pixels. This is a binary segmented image. The third one is blob detection. So the defect regions are enclosed within rectangular box so that you can easily identify which of the regions in this image is affected by tear. Now the fourth figure window, it shows the final result, that means the restoration result. Under the first column, the original image is displayed. Second column, the defect mask, that means the binary segmented image. Under the third column, the restore image is displayed. Now this is analytic measure, that means MSE graph. For various number of iterations, our proposed system is executed and the restored image is obtained. For each and every restored image, we have computed the MSE, mean square error value, and that will be plotted. This is the sixth figure window. This is another one quality measure, PSNR, peak signal to noise ratio. Similar to that means for various number of iterations, the PSNR value is computed and displayed here. This is another one quality measure, CNR, contrast to noise ratio. This is also computed for various number of iterations. By seeing these quality measures, we can conclude that our system is the best one for the restoration of images damaged by tear. Thank you.